Welcome to this special episode of Frequency Matters, the RF Microwave Update Series. I'm Pat Hindle, and I'm talking with Jerome Patoux, Director of Aerospace and Defense at Analog Devices. Welcome back, Jerome.
Good morning, Pat. Thank you for having me. It's great to be back on Frequency Matter.
So there's been a lot going on in the aviation market, so I thought this would be a good time to discuss the trends there. What trends are you seeing in the commercial and military avionics markets?
Well, some of the major trends in aviation and avionics today include decarbonization, future air mobility, autonomy, and cost reduction initiatives, with some overlaps between them. Decarbonization is a crucial one to meet the industry net zero climate goals by 2050, and will involve technology upgrades to airframe and engines on the long-term horizon, and upgrades to aircraft systems and operations in the short-term horizon. Future air mobility brings alternate transportation options like eVTOL or electric vertical takeoff and landing aircraft for fast and sustainable commutes in metro and regional areas. Autonomy aims to reduce human dependency and human errors in larger aircraft or enable fully autonomous operation in smaller ones. Both will require advanced technologies like AI, sensing and edge processing for safety and compliance. Cost reduction is intertwined with these trends as the industry is seeking to serve more customers, provide more services, and ensure a healthy future. Analog Devices is deeply engaged in this market, supporting customers with technologies that will shape the future of aviation and avionics, enabling them to meet those ambitious industry and climate change goals.
So you mentioned low emissions. It'll be a long time before hydrogen or electric aircraft are manufactured in any kind of volume. What can be done in the meantime to meet industry emission goals and still reduce costs?
So the aviation industry's aspirational goals of net zero carbon emission by 2050 suggest an earlier milestone of 20 to 50% reduction in emissions by 2030. So on the short term, some strategies can be explored to achieve this. One avenue is efficient and adaptive aircraft routing around traffic and weather formations to optimize fuel consumption and to improve safety. For this, the aircraft may use next generation AESA weather radars that can see farther and more precisely. In fact, the airborne weather radar market is projected to grow at a CAGR of 4 to 5% in the next decade. So such radar may use advanced technologies provided by Analog Devices, for instance, the beamformers like the ADAR1000 or GaN power amplifier like the HMC 8415. Another avenue is the use of new technologies to reduce the weight in an aircraft and therefore reduce the fuel consumption. Wireless technologies can reduce the weight of cables and connectors by up to 30%. And this is from tens to hundreds of miles and thousands of kilograms of cabling used in modern aircraft. So some initiatives already exist for that purpose. For example, the WAIC initiative, which stands for Wireless Aircraft Intra-Communication. Here again, Analog Devices can help with a well-known family of narrowband transceivers, or ADI can also help by enabling a better and more efficient use of wired resource using technologies found in our GMSL portfolio. Aircraft platforms introduced in the last 15 years, they have embraced the more electric aircraft concept, or also known as MEA, to promote the use of electric power for non-propulsive systems, which will replace gradually hydraulic and pneumatic and mechanical power sources and replace them with high voltage DC sources. So this reduces the weight, will save fuels, and can be also retrofitted in older aircraft. And Pat, as the industry is going to more electrification of aircraft, it will need efficient and high performance power solutions. And we can find that in ADI's portfolio of power management, power control, and power protections. So as you can see, the technology is already here at ADI to respond to a lot of the short horizon and longer horizon all those trends in avionics.
So how do you believe artificial intelligence and machine learning could help shape the future of avionics?
Oh, it's a good question, but we're still at very much at the inception of the S-curve for this. And we already so many possibilities. We're already witnessing the automobile becoming more like a server on wheels, with increased processing complexity. We believe similar trends are expected in aviation as the sensors proliferate in and outside the cabin. So AI and machine learning technologies are already being considered today in avionics for applications like aircraft health monitoring, predictive maintenance, flight control, autonomous operations, and customized cabin experience. So AI/ML can assist in optimizing routes, autonomously responding to air traffic and atmospheric disturbances, thus reducing fuel consumption, mitigating human errors, and eventually even enabling autonomous aircraft. AI can also provide insight as to the general health of the aircraft and its systems, improving safety for the passengers and also maintenance effort. In the military market, an aircraft in a hostile environment carry a host of radar, comms, navigational, and electronic warfare systems. The emerging threat no longer allows the pilots to manage all that complexity, and the fast increasing data payload and low latency require that more decisions be made at the edge. So AI can aid the pilot manage all that complexity, so the pilot can actually stay focused on the bigger picture.
So ADI has a lot of expertise in semiconductor technology. What trends within the semiconductor market synergize with the future needs for avionics?
So ADI and other companies contribute to invest in the development of functional safety ICs, and that's primarily driven by the automotive market. But the combination of quality managed process, onboard diagnostic, and functional safety documentation all lead to a high rate of reuse within the avionics market. Next-gen avionics designs can benefit from these ICs to reduce design cycle and reduce certification overheads. Engineers are typically under pressure to deliver a very complex system more quickly, and they seek IC models and advanced capabilities in modeling tools. LT-Spice, which is a leading simulation tool for designing power circuits, is becoming increasingly important as hydraulic systems leave room for more electronic solutions. The industry is also investing in compound semiconductor like silicon carbide for future high voltage power architecture used in avionics, for example. ADI is a key system provider offering reference designs with innovative gate driver and sensing solutions in collaboration with third-party silicon carbide FET manufacturers. As an example, the ADI MAX 22700 is an isolated gate driver IC with a leading common mode transient immunity and a leading propagation delay, both of which are critical for the avionics applications. That's essentially what we see for the semiconductor market trend that synergize with the future needs of avionics.
So maybe you can summarize for us, how does Analog Devices participate in the aviation market and solve many of these challenges for avionics systems?
Yes, thank you, Pat, for the opportunity to summarize this. So Analog Devices is a main electrification ecosystem partner and a leading supplier of technology for the sustainability upgrades. So we've been accompanying avionics customers in their quest for carbon footprint reduction, for enabling new capabilities in aircraft, all while helping to reduce the cost of flight. So ADI also provides cutting-edge technology for edge processing applications, whether it is for aviation, military aircraft, autonomous aircraft and UAVs, or the emerging urban air mobility platforms. So our advanced sensors, unrivaled digitization capabilities, efficient power conversion, and high-speed connectivity are leveraged for all these applications. So ADI's analog precision components are already widely used in aircraft system today, So these components are critical for measuring critical parameters with high precision in order to ensure a safe flight. We mentioned wireless connectivity as a possible avenue to reduce weight in aircraft. Analog devices offers a range of high-performance wireless transceivers that are designed to meet the stringent requirement of robust communication protocols. Some of ADI's RF transceivers, like the ADR V9002, for example, are integrated system on chip that are currently under consideration for WAIC connectivity in commercial aircraft platforms. And in part, that's because of their low power consumption and also their wide dynamic range. I would conclude by saying that analog devices addresses a very large span of avionics electronics in application that includes weather radar, battery management systems, power management, in-flight connectivity, in-flight entertainment, aircraft communications, and engine control. And for additional information, I recommend visiting the Avionics webpage on analog.com to see a comprehensive list of ADI technologies used in aviation applications.
Well, thanks, Jerome, for discussing the aviation market with me. ADI certainly has a great product portfolio for this market and many others in aerospace and defense applications. Thanks, everybody, for watching, and join us next time on Frequency Matters.